All right, problem 6, same general idea. Anya has 25 grand she wants to invest. She invests it in accounts paying 12%, 7%, and 6% interest. Account paying 12% is a higher risk, so she wants that amount to be less. Specifically, half she has in the 6% account. If her annual interest is $1,945, how much is invested in each of the different accounts? So we want to know how much money has been invested in each account. So let's let A represent our first account. So it's going to be the amount of money in the, what was the first account listed? The 12% account. So A is money in the 12% account. B is then money in the 7% account. And C is going to be the money in the 6% account. So one equation that we're going to be able to write is the total amount invested, which means A plus B plus C is 25,000. Next, we're told that she wants the amount in the high risk account, the 12% account, account A. She wants that to be half the amount she has in the account paying 6% interest. So how can we figure out how much is in account A? Well, we can take the amount that is in account C, the 6% account, and we can divide it by 2 because we want half of that amount. Now we need to rearrange things in order to be able to enter this into a matrix. So we're going to need A plus 0B minus 1/2 C equals 0. So all I've done is I've subtracted that C over 2, that 1/2 C, to the left side, which left 0 on the right. So I have that. Last equation now, her annual interest is $1,945. How much is invested at each rate? So to get our last equation, we need to use the interest earned. So how much interest do I get based off of account A? Well, I get 12% of what I invest. So if A is the amount invested, then 0.12 times A is going to represent how much I make. Plus, then B, we get 7%, so 0.07B, plus 6% of C, so 0.06C, equals the amount I've earned, which is 1,945. So my matrix, again, is just a matter of writing down all these coefficients now. So 1, 1, 1, 25,000. Then I need to use that modified one, which is 1A, 0B, and negative 1/2 C. Gives me 0. And then finally, 0.12A, 0.07B, and 0.06C should yield 1,945. So RF that using the same process as shown in problem number 4. And you should end up with the matrix printed to your screen that, again, gives you an identity matrix on the left, so it looks like that. And then on the right, we should end up with a 6,500, 5,500, and 13,000 right there, which again corresponds to A, B, and C, the 12% account, the 7% account, and the 6% account.